Okay, hi and welcome back. This is a little bit of a project which is basically I'm building this to test a crystal that I've taken out of the Sony ICF-2001D, because what I want to make sure 100% before I start messing with the crystal circuit is that it is the crystal that's causing an issue and not the PLL chip, PLL IC. So what I'm doing here is I'm building a crystal tester. Now this is G3PTO. Now there's a video that I watched with somebody making this, and he suggested changing this value, which I've actually marked it now as 47K in the actual schematic from G3PTO. It says 4K7, which is 4.7K. Well, I'm not sure how important that value is, but this has got a couple of advantages. I've looked at quite a few of these circuits today. First, it uses 2N3904 transistors, which I've got loads of those, so there's no issue there. I literally got about 30 odd of those, so very common transistor. I've got all of the resistor values, luckily. A little bit scratching around to find them all, but I've got them all. I'm going to use a 9 volt PP3 battery, so I've got this ready to go. For the crystal pads that's marked down here, I'm using one of these. I've got a crystal here. Crystals come in all sorts of different shapes and sizes, so what I'm going to do is I'm going to common two of the terminals together, so this will fit in there quite nicely. This is a standard, I think it's an HC49, something like that. I'll find out the exact CAN spec in a minute. This is a crystal that I've got to see if I can tweak to the right frequency, so this is quite important. So yeah, that's that'll fit in there. And if I've got wider crystals, some of the older types are much wider, then I can hopefully get them in those two outer sockets. So I'll just gang two of those together on the circuit. Let's say I haven't designed this. The way it works, I don't know. It's a bit of an experiment for me. If you go and search online, you'll get this document come up. So it's to test the fundamental frequency, and basically you stick a frequency counter on the output there. This shows a capacitor, but that capacitor is in your saying that I could probably put a capacitor on the output. It doesn't state that on there, that I can put a blocking capacitor in that. But, there is a capacitor in the oscilloscope probes which I use. If you turn it to the 10 times, I believe it switches a capacitor in. So that's the idea. I'm going to build that. I'm going to put it on this piece of Vero board, or strip board as you call it. People call it different things, but that's the plan. And I have somewhere got a little box, so I might build this into an actual box to make it a bit more permanent. So I'll have to have a look at that. Might be easily done, I'm not sure. This is going to be the tricky bit to get into the box. Probably have to make a cutout somehow to get this in. Yeah, not 100% sure yet. Anyway, I'm going to start building this. I'll build it from this side. It'll go in, and I'll solder everything up. Hopefully it'll look nice, and it should work. So I'm going to have a few trial sort of put-togethers on this. I might even breadboard it out first as well. That might be worth doing. Stick it on my breadboard, make sure it works before I do anything else. So bear with me, I'll get that underway and see it. Okay, well, my little oscillator test circuit is built. As I say, I've used this this schematic. If you Google G3PTO crystal tester, you'll need to change this from 4.7 to 47K, which I've done on this diagram. And I've just done myself a little quick ready reckoner of what the layout for the transistors are. I mean, I've got plenty of these, so that's perfect for me. I've literally had to buy nothing. I've had everything to make this circuit here, so that makes it even better. So you can see I've hooked up a crystal. The idea is I'm going to pop this into a little box so as I can keep it for future use, because as I say, it would have saved me quite a while if I'd already had this built. So bear with me, I'll show you what box I'm going to look to put it in. Okay, well this is what I'm looking to build it into. I've only got the bottom cover at the moment. I'm not sure where the top piece is. It's up in my rack in here somewhere. I've got a bit of a messy bench at the moment, so I need to get that sorted. But basically, we've got some fixing holes in here which should work nicely. We've also got a battery door, which would be brilliant because you just pop that open and my 9-volt battery will sit in there quite nicely. What I want to try and do is pop that crystal out. So what I want to do is cut out a piece so this sits out of the case, if you know what I mean. Then I'll be able to just attach pieces in and out of it, attach crystals in and out of it even. And this is my output wires for the scope or the frequency counter. So what I'll do is I'll mount probably down beside here. I'll mount a BNC connector for that, I think, so I can just plug. Well, actually I don't need a BNC connector, do I? Because I've got that on there. I don't know. I'm not 100% sure what I'll do there. I might just have a couple of banana jacks maybe. Not sure, but anyway, that's a future thing. Just for now, we need to make sure this works. So I've got my desktop sort of frequency counter here. Let's see if I can get that a little bit better in shot for you. Just line all this up, bear with me. I've got a crystal in here at the moment. Now I know this crystal is a 6.25 megahertz. This is brand new from Mouser. 30 picofarads now. I don't know, the significance of the picofarads is apparently that's basically the insertion value of it, how it affects the circuit. So when you put it in circuit, it adds 30 picofarads into it. Now I'll check that in a minute. In fact, no, I'll check it now. Let's get my capacitance meter, connect one of these up to the capacitance tester and just see what value it actually is. So there we have it. Let's pop that on. So that says 5.1 picofarads. So I'm not sure what 30 picofarads means, but you know, I thought that was the insertion, and this is the crystal that we're concerned about, which is out of the 2001D. I mean, that has got next to no capacitance unless it's, as we suspect, dodgy. Anyway, I'm not an expert on crystals. There's so many different factors. When I contacted a crystal manufacturer to try and get a new one of these, which is 6.275 is the value that we're looking for, they actually asked me so many parameters, totally lost me altogether. It really baffled me with science, they did. Not difficult, I don't suppose. Yeah, let's make sure we can get a good view of that. So this this crystal's in the circuit. What I've done with this underneath is I've ganged the two together, so we've got a little jumper in there. You can just see it here. You can just see it in there that links these two terminals. So really, as long as I put it between this one and either of these two, I've got a connection. So let's pop some power on it. All I'm using is a 9-volt battery. The circuit says 9 to 15 volts. Let's just turn my scope on. So say the frequency we're looking for, not scope, frequency counter. We're looking for 6.25 megahertz. So it's going to connect up to this. Scope probes have seen better days actually. So you can see we've got 6.249 which is pretty close. So let's pop that one out. I mean that's probably within tolerance. I'm not sure what the tolerance is on these. Let's pop the next one in. This is again the same value. Well, that's exactly the same, 6.2491. Don't have a time, I'll make that any difference. Nah, it just adds more zeros on the end. So before we get right to testing the one that we're really concerned with, let's try a couple more. I've got some old CB radio ones here, 10.24, all those into CB radios. UK FM always uses 10.24 crystal. Okay, sorry about that, phone went. So this is a 10.24. You can see it's pretty close, 10.23886. Pretty good. Let's try something a bit more obscure. Let's find what have we got here. Well, this one says 6. That one is pretty much 6.009. So the main one that we are interested in, let's move these out of the way, is this one here. This is the one out of the ICF-2001D, so let's see if that'll fit in there. Yeah, so you can see there that I had to tap it to get to work again. So it's actually at 6.273 at the moment, so it should be 6.275. It's pretty close. Okay, I've now got my scope probe on as well. So that's my scope probe. That's my probe for the frequency counter. So I've got 6.27324 on there. So let me get you to the scope. Okay, hopefully you can see that. So this is my frequency readout. You can see the waveform there, and it's showing us 6.27327. Now this one's saying 6.2324, so I'm sure if I extend it a bit further at 273239. So it's not far off. I mean, probably don't need the frequency counter with this measuring it. Just zoom in on the frequency a little bit better. Yeah, so it's fairly stable, that. Yeah, quite pleased with that. So let's try another one in. Let's go. Well, the one thing, the reason for doing this is to tap it and see if I can get it to drop out. There it goes, gone. So tap it again. There he's back again, so that does prove my theory that the crystal's knackered. That is definitely yeah, it's back again now. That is definitely a dodgy crystal, unfortunately. I was really hoping that it wasn't. Next thing I was looking to do is add in some capacitance. So if you think I've got that at 6.275, which is knackered, technical term. Let's pop one of these in. This is our possible replacement. So we're looking at 6.2491, so we need to be 6.275. So we need to add, that's 50, 60, about 25 hertz into that. And I've heard that you can do it with capacitance, just adding capacitance in series. So what I want to try and do is rig something up where I can adjust the capacitance. Okay, and welcome back to the ongoing Sony Fun and Games. This is coming from Manuel in Spain. Very kindly sent me a crystal. So what I'm going to do, I'm just going to connect it up to my little test oscillator here, just to make sure that we're roughly on the right frequency, and that everything is all okay. So it is. If you can see that, let's just zoom in. It is a 6.275 crystal. Brilliant stuff. Right, let's just connect it up to my little test oscillator. Let's turn my frequency counter on and pop the battery in. And there we go. If you can see that, 6.27320. So again, I'm not 100% sure how accurate this oscillator is, but it does give a good indication that we're pretty much there. There is a trimmer capacitor in the circuit anyway, so we should be able to get that sorted. So brilliant, it's working. So bear with me, I'm going to put it back in the radio and then reassemble, jig it all up and see if we can get it working.